this is an exploration of using generative AI these days for generating Shiny apps, or in general, planning projects and designing in software development. I found it could be quite useful to get into exploring new frameworks and going headfirst into some maybe unexplored coding paradigms or even frameworks in general. And it seems to be also for some people could be a stimulating learning experience, an interactive learning experience. You can ask questions as you start developing with a new framework and plan along using AI assistants. So in this case, we're looking at, I haven't developed Shiny apps really in a long time in R, and it was kind of rusty. But I had some ideas about how I would like to have an interactive app and to explore some differential expression results in R and compare them. So I was thinking how it would be good to start with a framework like Shiny, but also improve with what is a Bootstrap library. Posit had this add-on, which is an extension of it. Actually, it's a complex R package that, as you say, asked actually AI. After seeing a few screenshots about Bootstrap library, I asked here to give me a summary of it. But of course, you can find on the Posit website the demonstrations and presentation of what they can do. So this is RStudio website, and they can actually launch from our preview of their, because basically Bootstrap lib or BSlib, I would call it shortly from now. It's a library. It adds most of the theming and layout powers enhances the layout powers and theming of recent versions of Bootstrap, which is front-end styling library. So it's a little bit, it can provide HTML standalone without even working with Shiny, but the easiest way to get into to benefit of full interactivity on top of Shiny is to use them in combination with Shiny apps. So they have this simple demo that you can just start. In this case, I just started by using this command. If you install the BSlib module, a lot of warnings because of the window size, I think. But basically, the command is here that we just run this in R, and it's going to start this full demo application, which is this one here, which is an interactive dashboards and a lot of. So this is on top of Shiny, but it provides full access to a lot of advanced HTML and JavaScript widgets, tables, and mostly used for theming. So the fact that you can customize the themes for your applications by just including this library. And so this is quite complex, besides not being very familiar, a bit rusty with Shiny. You can also, I also wanted to have this nice card layouts that only the library provides, BSlib. So interactive theming, it's really nice, and you can also expand the plots to fill in. So a lot of interesting features here and polishing that and theming that the library adds to a Shiny app, including folding sections, sidebars, and stuff like that. So of course so I started to think about how would I start developing such an application, not only with Shiny, but also with this framework, which is kind of unknown to me in terms of how it works, and it's sometimes not easy. There are a lot of examples, it's very well documented, but starting headfirst in a complex application, it could be difficult. So I thought, let's make use of the generative possibilities of helping with this design and implementation, especially and making a modular structure that I can take over after scaffolding the application. I could take over and see how plug in my own code and analysis in there. So for this, there are many frameworks, IDEs today, but that integrate generative AI development, but they're mostly for complex applications. Especially, you have to pay a subscription So I experimented quite a bit with one of the more advanced models here, which are from Google Gemini. Google, they provide this Gemini model. And this is the latest one. And this is AI Studio it's very good for explanation, and it's free to access to experiment and access these very good models, large language models. In this case, this is their latest offering, and it's up to par with offers from ChatGPT, and mostly are forefront right now, but there are a few other models coming. And here, this interface could be at least a bit intimidating, but I will try to go through how you can use it for this simple, actually complex purpose to design and start implementing Shiny plus BSLib application. Now, just a few words about introduction about how large language models generally work. They have this. They actually use words are split into tokens and assigned the numeric values. Usually, this is how our natural language is converted into numbers and processed by these complex numeric and models. And these tokens that you'll see here quite a bit on the interface are just fragments of words, prefixes or suffixes, and basically it's parts of the word that are having, based on, I guess, on their frequency of, and they are taking into account by these complex systems to predict the next words, or even to kind of assign some semantic meaning sometimes to the whole text sometimes. And it's a very complicated thing that most actually even ML machine learning researchers don't really know exactly how the whole thing emerges, but the results are sometimes impressive. So that's why when we talk about tokens here in our AI Studio here, whenever you enter text here, you'll have a token count and telling you the upper limit that the model can support. And this is 1 million tokens. And if you convert this into words, it would be probably generously, if they are shorter words, it would be like maybe 750,000 words. So it's a huge context window that differentiate this model from others at this time. But what does it mean? And it's also multimodal. So the way in the sense that you can take input of images, so you can kind of see what's happening there if you provide an image. So this is how I started the design, and for this application. So I was thinking how I would like it to start. So I just made this mock-up with using parts in Google Drawings, or you can do it in Slide or something. Just copy and paste, Shiny controls and stuff, and how I would like this to be our overall UI design. And the way I started is to just upload this, basically this screenshot here. Let's say, or you can save the image, but basically the actual application design, the interface design, can go in. Well, I'm going to clear this conversation. Yeah. Okay, so now the 0 tokens, but I can start by pasting this here, and along with my prompt. That's how I started to experiment. Just you put whatever you want to develop, right? And it will can sketch the code and the structure. But this is only if you start typing here a prompt, it's going to be probably the results might not be very good. A simple prompt, I mean. But so I prepared in advance much longer prompt. But there is another thing that I would like to clarify before that. There is something that in the world of large language models, there is this system instructions concept, which is like instead of priming the model, the language model, for the conversation that's going to follow, and basically telling how you would expect the model to behave during this conversation. So in this case, of course, I experimented with what would be useful for this kind of use of LLMs develop R-Shiny applications. So I want to make it somewhat specialized and guided in terms of tone of the conversation. So this is done with what's called prompting, right? And usually there's, sometimes these libraries of prompts. And so I made, after some iterations, I have this system prompt, which, as I said, is something that primes the conversation and directs. It's quite long because, you can use, of course, natural language, and it takes quite a bit to explain how you want the output for each conversation. This is about coding, so I have some instructions here about iterative code revisions and how I want the output to, so I can copy and paste it in my development environment, which is VS Code for this example, and using some tricks to make this process a little faster than just copy and paste. But also how I want the code to be written, because you can guide the model to use, I prefer shorter variables and function names and a lot of personal preferences. And since I'm dealing with a lot of points, is this different expression for transcripts. So for the plots I use can be 100 to thousands of points. So I did have some guidance here about, in terms of data efficiency based on my own experience with large data sets. I said here that I prefer data table for the data manipulation. Anyway, so the way is basically you can have this library of prompts or system prompts for specific purposes, and so I save these documents and I put them here. For example, to start this, I'm going to add this system instructions prompt here, which is going to be, somehow it has for each point, at each point every point in the conversation, every back and forth, this system prompt is kind of a reminder for the model that I want these rules to be followed. The problem is sometimes it's not that easy to follow because this gets mixed in with the rest of the contents and the whole conversation as part of this context that's called that whole token context window here. I would say, let's see, Shiny planning. I just want to, because this is saved on as you develop and you continue this conversation, it's gonna be saved on your Google Drive in your Google account. Test, okay, whatever, yeah. So just the interface is a little cluttered here. Now, for the main prompt to start the conversation, this is gonna be my, I would say, product specifications, right, for this app. What I want to send, and I want the model to take into account not only the image that I made here, but also its functionality. So I would have to describe, because, and of course, my design is not giving away how this should work. So I have to provide an accompanying documentation, which is always good to plan in advance, right? Now, the idea here is that sometimes you have to iterate quite a few times to convey what you want to obtain. And since the problem here with these language models and the way they work, it's often non-deterministic, the output. The responses that you get, you might not get the same response twice for the same question, for the same input. And there are some parameters here that you should, most of them don't matter for this presentation, but temperature would be one of them, because they say it's creativity is related to this. That means how much it deviates for each answer around a specific convergence point for a response. It's not that easy to explain, but basically the idea would be, intuitively, if we lower this parameter, it will be a little bit more stable. But for the past couple of days, I played with zero temperature, which theoretically should provide you with reproducibility in terms of responses. But that's no longer the case with the models nowadays, especially these so-called thinking models. They're very advanced, and the temperature here is probably too simple of a parameter to make it deterministic in terms of answers. Increases the chance of getting similar answers and similar output, but doesn't make it reproducible. So the thing is, I also noticed that sometimes some models, and even Gemini thinking models, maybe have have weird behaviors when the temperature is very low or maybe some undesired. So I would probably set it somewhere in the middle. It's really an experimentation thing. But so I would just set it like this, or set it like this for now, like in the middle, just to be somewhat. I mean, there is the concept of hallucinations, right? Maybe you heard of in terms of language models, actually making up stuff, and apparently lowering the temperature lowers the chance for that to happen. But in this case, so I tried a few. That's the description that I tried to make a comprehensive description, and it's most like. Um, for the application, right, that I have in mind. So this is like a free, sorry, is it? I don't know, access this. So yeah, this was design. So now the first prompt, which is a huge description of what is on the image that I created, the UI, it's about how the application works. And I noticed in my experience with the large language models that it's good to use to shorten, when you describe how things are supposed to work behind the UI. And in general, it's good to name entities like variables in programming, in coding, right? So in this case, I'm using shortcuts for some of the terminology that I'm using, like DRES for differential expression results. And also I named the picture that I attach, ref design, so I can come back to it in the text and make it easier. Now, in terms of design, I have two sections. A data loading section, which I shortcut as DLS whenever I need to mention it to the model, and concordance and visualization section, assessment and visualization section, which I shortcutted as CAVs later. So the models recognize Markdown, so you can use this kind of title delimiters to show this various section. Now, so here I kind of describe what I want to get from this app and how it should behave. So it's a very long thing. It was an iterative process. And also I realized if I want to describe the application, yes, there is a lot to, and so it looks long, but that's the good thing about this particular model. Gemini has a very long context window, so it can take volumes of text. The problem is how well this is going to be informative for the model. That's a separate discussion. I mean, it is because of course it can refer to this back in that conversation, and it has a somewhat stable memory, but it can get confused when the context becomes much larger than this. Yeah, so this is, it looks very long, but again, it's part of the development. It's a way to describe what you expect, and it's a way to organize thoughts too, I thought. So let's see what it does with this. Well, actually, yeah, let me prompt it here, and this huge prompt, but should show me tokens. I don't see that. Yeah, the instructions here are quite complex, a lot of things to get, but it's really like discussing with somebody what you expect from this application, right, to do and how it should work. And actually, I'll show the prototype because it might be a long, complicated process and non-deterministic, as I said. So from one of my previous iterations, I'm going to show how this work. But let's start this prompt then. Okay, so I have the system. Yeah, so the process, while it's gonna be, okay, so if I run this prompt, I hope it works. Okay, this is gonna take a while. It can sometimes take minutes for very long prompts like this one. We'll let it, okay, the token count is pretty low compared to the total window size, which is 1 million, as I said. So right now, from what I uploaded here, including the image, it's only the 3,000 tokens. Okay, so now just to show what we're gonna end up after a few iterations and not knowing much about Shiny, and let's see which one is it? Oh, here, the iteration. So yeah, these are actually two separate iterations. This is a more initial, more early one, and just mock-ups, and the other one has a bit more functionality, and I actually had to tinker a bit for the layout, because that seems to be the biggest challenge for this particular model, maybe, to get the shiny layouts the way I wanted them in the picture. It seems to have some trouble coordinating between Bootstrap, the web front-end libraries, and styling, and R code and Shiny. So right now, this works partially. There's a lot of implementation. This was quite only like what we call a few shots product, in the sense that you send a long prompt and you iterate a bit on it, and in a few prompts would be, so one shot is if you get the whole application in one prompt, which is can happen actually for web front-end applications these days, but for R and Shiny and complex requirements might not be. So here, well, the idea what would this simply do for now. The first tab is implemented. So again, I didn't write most of this code. I wrote the specifications, right? And I tinker a bit with the layout, but that huge prompt was describing what I want. And then because the code, I made it explicitly said to be modular, I can go in and enhance the parts that I want to focus on. So yeah, this one here is a simple T statistics correlation, but between these two data sets. But yeah, I wanted to make it like interactive in the sense that you can, only look at the top p-values above some number, some value here. Sorry, I mean lowest, lower than this number here. And or you can look at top 350 or something. These are actually two discordant data sets that DE results, differential expression results that I loaded here. So basically, we're looking sometimes at the top 350, and in this case, there are only overlapping features. There are only 6 overlapping features, and the correlation is. Well, it could be high because that's not the problem with the rank correlations. We are looking at when you have a very low overlap, the correlation could be huge, but it doesn't mean that these differential expression results are actually correlated. So usually you don't do correlation on a subset; you do it on the full range, right? This kind of rank correlation. So I put it like it was initially. All right. Yeah. Okay. Which is more realistic. Actually, you can tell it's very low. It's 10 times lower when you use the whole range. And what I try to do here, and I asked the model to try to reflect, it's an approach of looking at how each point is contributing to this correlation in the terms of rank concordance. In Spearman is using a formula where each rank is checked against the distance between each rank and the median, and mean is taken into account in the Spearman rank correlation. So it's kind of obvious what's happening here. You have higher concordance in these quadrants in red, right, and lower on the opposite because they have different directions, right? It's kind of obvious. I mean, yeah. So this is something that, again, I only guided the model what to implement and how. And this particular challenge here is the number of points. And for that, I did a simple research before what would be the most efficient way to have an interactive plot, like we see in Plotly here. You can see the genes and the gene IDs in front. This was basically asking, and you can also Google and search the information about what would be the most efficient way of doing this, and it's Plotly. We're using the WebGL extensions, and I think actually that's part of my prompt. So there are some guidance there related to performance in terms of this section of CAVS. There's a Plotly scatter GL, I think. Yeah, let's see. Scatter GL. Yeah, right. So this information I had, I mean, I think the model might have figured it out when I mentioned hundreds of thousands of points, but it's good to guide so in advance. So now if you look at the output, part of my prompt was to not generate code, to show me the plan and the way, show me the plan about, the whole, how the design would look like. And this is also a good way because it's going to summarize my prompt in a way that's actually applying to the implementation and the components. So it's all structuring the the application, right? So what I would do then, I could use this as a product specification, like a README MD, and just to keep it right, because this plan here is describing the project and the implementation that's proposing, including the file structure, right? So I copy all this here and go into my, I think we can import this demo.
But it hasn't like actually given you the code yet, right?
No, because actually my prompt is telling, no, don't give me the prompt. Show me the plan. So it has to be an incremental.
Yeah.
I mean, I thought it would be good because I want to supervise the planning.
Yeah.
And actually, this is part of the learning experience. And I'll show. Let's see. So let me just add this. So yeah, it's just adding a README. And this is good later if you put this plan of implementation plan in a file, right? Later on, you can start a new prompt with that all documentation. It gets an implementation plan, right? Because you can start for iterative, development. You can refer to previous to the original plan. That would be easy. Okay, so let's just, of course, this includes, my. I asked, so this is all coming from my initial large prompt and the actual system prompt. Always says, do not implement. That was my prompt I'm going to provide them. The system prompt was saying, always ask before writing more than 4 lines, generating more than 4 lines of code, which would be a lot here, right? It's more than 4 lines for this whole thing. Ask for me to review the plan and the implementation before generating the code. Anyway, so theoretically, if I want this to be the documentation, I would just delete here, right? The blurb. I could have, basically it's just describing the project. That's what you want to save here, right? The plan. Of course, it's good to the way it's done. Now, in interest of time, we're not gonna go through all the details, but I can tell you the plan already sounds very sound to me, especially because the model has a good idea about how this would work. The knowledge is impressive sometimes about Shiny and everything, but the problem is that the problem is sometimes is in the details. So when it starts implementing features, some there is no enough precision sometimes, so it might be some iterations to correct some bugs and everything. And anyway, still for planning is like, the discussion with the collaborator about how would we develop this application based on my verbose initial description of what I want the application to do. This is starting towards the application design, the actual implementation, right after. How would the implementation work? So for this, actually, to make it even clear how this application would work, I said, let's generate a workflow diagram, right? Because I'm new to Shiny and to this whole planning for this Shiny app. So I know there are modules, and I asked specifically to be very modular. And there is a concept of modules in Shiny that I actually learned about by looking at the code and see how the files are structured. So if a follow-up prompt would be, let's see a mermaid diagram with the overall, how the files connect to each other. This is, we can also visualize in VS Code. So, let me go to this. If I just go here. I already, because I had some iterations, sometimes it forgets to put double quotes in mermaid. So mermaid is just a diagram framework. Diagramming, you'll see, hopefully it's gonna make a lot of mistakes. So the last paragraph here is because in previous iterations, I got some mistakes and it wasn't looking too good. This shouldn't take too long, actually. Is it going? Now, if you look at the token count here, its own previous responses also count in this. So it's not just my input, it's also its own output. And actually, sometimes while you wait for the answer, it's very interesting to look at what they call thinking trace. So which actually it's, for me, it was, a way of approaching a question. It's generic, right? And it basically commenting, it's like an inner monologue, right? About what I want the user and and this is a good summary of my requirements, right? This could be inspected too, because after it provides this so-called thinking, which is usually hidden in the final result, then based on that thinking trace, theoretically the response is generated, which actually is a bit controversial because recent research shows that sometimes the thoughts are not fully reflected in the final answer, which is a problem still being studied. But anyway, so the summary, that the plan that proposed, as I said, I copied them there. Now let's see the diagram. This, I don't know if probably not familiar with Mermaid, but it's a specific language for graphing, and so I can just copy this and let's preview it as a way of documenting and this plan. So if I go through here, start a new. So this would be, let's say, the diagram D. And well, for the ID, for the VS Code extensions to recognize it, I would put like markdown style, the type of content that's coming in here, which is this one. And now we should be able to preview it. There are some extensions that let's see if this works. Yes, okay. Now, yeah, sometimes the diagrams are a bit too hard to read because I haven't figured out how to zoom, especially on small screens like this. But these are actually the name of the files and how do they relate to each other, and it's server logic. There are some compartments here. Zoom in on this screen, and I don't know how this application actually zooms in here, but yeah, I guess it's a way of starting. At least you can, these mermaid diagrams can be later edited manually if you really want to. So, but for now, I just wanted this to have it in my documentation here. And it's a way to visualize the files, the modules that were created. So as per my instructions, there is a global, it cannot be seen, I suppose. So yeah, that was the description here. Actually, we can see it better here. Okay, we don't need the diagram now. Okay, yeah, so the project structure is something that I get similarly generated every time, even though I specified to use the UI prefix for the UI modules and SRV. That was part of my long prompt about this, how I want the files names generally, but still in the generated code or even this plan, sometimes the files are named differently. Even with zero temperature, there's still variation there in terms of even file naming. In this case, use these strange names. I can tell it to change this naming because it's kind of obscure. DLS comes from my specification from the download section, a data loading section, and calves is the right side of the, but I guess it's an easy shortcut, especially because it is documented. Well, here, this calves main panel, it's not, unless it's documented. Oh yeah, it is documented above. So it kind of makes sense from a programmer's point of view to use these kind of variables and short naming, but yeah, that's a good start, I think. Now, yeah, it summarized my requirements here. Now, of course, the trickiest part is generating the code, and especially when it's modular like that, it's gonna be relatively. First of all, you'll have multiple files being generated, so multi-file editing and creations here for the model to manage, and it can do it. And sometimes, most of the time, the application actually works without syntax errors or something. But if they appear, they are easy to fix. Let me see what we get here in the first shot of generating code. So if I go to, does it here? So I prepared follow-up prompt because sometimes I want from now on, I want the stage implementation. So I decided to have like 3 stages to check after each stage the code generated. Stage 1 being the UI mockup. So I just want to see how the UI, how close it is to the design that I provided in the diagram there. And that's actually the most troublesome in terms of matching the design because of handling between of the web front tools and our code, I think. But it's mostly there. So yeah, the first iteration, as I showed, could be a bit clumsy, but at least it generates. So what I'm asking here actually to generate a runnable, something that I can run, I can launch the Shiny app and I can inspect the layout. So there's no functionality in the backend, in the server side, except I ask here for linking the slider for a maximum p-value threshold. But it should allow me to inspect the layout and how close it works. And I can tweak it before moving on to the backend, to the server functionality. So in this case, I copied this. Let's see, this is, oh yeah, at this point I noticed that since the context window is so large, in order to provide the BS library documentation might be needed because it's somewhat new library, and I think when this model was trained and the frequency of uses for this a particular library and across the training materials might not be very precise. So sometimes I noticed it's useful to attach to a prompt specifically about the UI some of the documentation of the BSLib modules that I think can be used. So I went to the BSLib documentation and I just pulled these files, I converted them to Markdown here. I use just a few of them. So basically, these are from the rocks R-Oxygen documentation. I converted RD to files to Markdown because my RD has the little extra tags that I don't want to use. Okay, so yeah, this is somewhat cleaned up, even though I noticed that there's still some oxygen tags there. But anyway, here, basically the way you can just drag and drop files, I hope it looks nice. So I selected some of the components that I think are gonna be involved by looking at the overall the theme, the demos that I saw. So they are just added to the documentation. And I noticed that it's interesting when it extracts tokens, they are very low. Of course, a lot of space is streamed, so they're much lower than the file size, which is a good thing. It doesn't add too much to the tokens now. So now is a bit of a die rolling part because sometimes the output might not be as close as I wanted. And the good thing, you can always resubmit a prompt and get a different output that is closer to what you want, a little bit closer at this. The problem is without integrated development, this is getting complicated in the terms of testing. You want to have feedback for a specific output, like creating the code. You actually, at this point, without the paid IDE, it's kind of hard to copy files into. I mean, it's not hard, especially when you have multiple files. As they are generated, you want them copied in your development environment to test the app, right? Well, I don't know why it stopped here. Oh, no, it started. Okay. So what I instructed the model, I don't know if we have. Oh, wow. Okay. I instructed the model after each file to also show me the file name so I can easily save. For some reason, this time it put it in the actual content of the code, but it's okay. It's a comment, so it doesn't matter. Now, what I want to just save this one by one and put them in the IDE, right, to test the output. Okay. So this was globals. So I'm just saving. Yeah, this is the laborious part that nowadays integrated development environment like Cursor AI or even the paid version of GitHub Copilot in VS Code can actually do this kind of multi-file editing and integrating with the LLMs. But so this is the version that is free in this case to do if you have the patience. For multi-file solutions like this, it's a bit tedious, at least the first round. Okay. I hope I didn't skip any. So I'm gonna save these. Yeah, there are a lot of HTML code there that I don't necessarily like because that's usually is not very precise. But we'll see, because that's another thing. After I get the layout, the running app, I can put the screenshot back in here to discuss fixes, which most of the time works. So, okay, I'm not sure if I paid enough attention. Oh, it says this was okay. I might have, and yeah, that's not a nice way of doing it. But for the initial creation of the files, unfortunately, this is related also to the iterative testing, so it might take a while. So now I think we should be, see, this is going to be an R directory has to be created, and I'm going to put this one here. If I didn't mess up the names, well, like I'll see that in the quite quickly, I suppose. And usually it's just here. That was a structure that was proposed. And now I can actually test if I was lucky and actually copy the files, right? And go testing. Here I'm using Radian. So yeah, if we just, unless I messed up these file names when I saved work. Okay. So there is a problem with the file input. We are recording this part of the presentation at a later date, so excuse the differences between this part of the recording and the previous one. We are just picking up where we left off. The initial run failed due to a syntax error.
which seems like the model added this progress parameter for the file input method. The progress parameter is not available for this file input parameter. I guess it was requested at some point maybe, but definitely the model made this up in this case. And also because I insisted in the prompting to try to disable the progress bar. But it's easy to fix this right now by fixing the error by removing the progress parameter. On the other hand, we'd like to know if there are alternative solutions, right? And the model might be able to tell us that. So we just copied and pasted this error message into the conversation that we started earlier for this project in AI Studio. And I just told him that I got this error. Well, as sometimes does, the language model apologized, but acknowledging the error, but on the other hand, proposed another solution. So first of all, to fix the part of the code that where this progress parameter appears as an error because it's not accepted by the function, and also to try a different approach by using CSS applied to the HTML components of the app to hide, to provide some styling attributes that will hide that part of the UI. So after asking for the approval for this plan, as I instructed the model to do before every code changes, it proposes 2 patches to the existing source code that it generated earlier. So these are the one to fix the parameter that doesn't exist for this function, and the second one is to apply this CSS change to the main app code. So in this case, we'll apply these patches using, for convenience, using this diff and merge extension that I installed for Visual Studio Code, that actually has this interesting functionality to very useful for this kind of use with a large language chat configurations, where it can perform a diff between the clipboard and the current selected file. So I can invoke this functionality of the extension, and for that I use this keyboard shortcut for convenience, because I think by default you have to use some sort of command from the menu here, or maybe it has a shortcut that conflicted to existing shortcuts that I assigned. So basically I assigned here this particular functionality to compare current file with the clipboard content with Ctrl-Shift-A here. And these are all my, for the current session, these are all my custom shortcuts that I assigned. By applying this to the UI, the source file that has this error, by invoking this functionality, we get this diff UI that is available in VS Code. But in this particular case, the extension was able to compare clipboard content with the existing file. So we just have to apply this change, this very simple patch here. I move it to the right side here. I can save the modified change, modified file. And now we can see here that the progress parameter disappeared. And the model also added the comment for that, which was unnecessary, of course, but that's how Gemini does it sometimes. So now we can run this application again to see if that was the only error. And it looks like it was the only error in terms of syntax correctness. So now this multi-file application, Shiny application, was started. And in order to fully inspect the Shiny application layout, we'll start the application in the browser, how it's normally used. And here we see that, yeah, we have the tabs, the overall structure of the application is similar to what we requested. There are some differences in terms of the spacing between elements, the buttons, the styling. Of course, it doesn't match exactly what we asked for in our imaginary layout that we put together, the mock UI just diagram image that we fed to the model. There are some changes that could be prompted from now on to the model to increase the font size for some elements, or we can go in directly edit this. But the overall layout is there exactly as we requested it. The two sections for loading the two files to be compared. And because I only applied one of the changes that it suggested, the one that had triggered the error for the non-existing parameter, we'll see that the file input progress bar is right here. The long blue bar here is the part of the file input control in Shiny, and the one that I actually wanted to disable, and I asked the model to hide it. Now, as we saw, the first attempt was to just consider that the file input method would have this progress parameter, but that was more like wishful thinking from the part of the model, I suppose, the language model. So now I would apply the second change that it suggested, which is another potential way to hide this part of the file input control, this UI element, the blue bar, the progress bar. So let's do this by applying the second change it proposed here to hide that progress bar, which is this little code block here. And again, I use the same approach by using diff and merge extension, by copying this into clipboard, going into the VS Code application. This is actually exactly for this section here, but let's see, even without knowing that, just running my diff and merge shortcut here, you should find the proper place to add this function, this patch. So I'm just applying the patch, save, and now run the patched version, and we should see see now the format, the part of the app that doesn't longer show the control, the little progress bar, the blue bar that was below this control, and I didn't want to be on the UI in this layout, is no longer there. Of course, for both controls should be the same. So now it's closer, even closer to a little bit closer to what we wanted for this portion of the layout. And from now on, yes, we only have this functionality, quasi-functionality, very basic, that links these two controls that we asked to implement for this very initial run, just to see that the overall structure of the multi-file Shiny application is coherent, and we can have a mock UI display and to improve, to work now iteratively on maybe changing the font sizes where needed, and make it more compact. So that could be a dialogue now back and forth with the model, with the language model, to discuss, to fix this layout, to bring it closer to what we wanted in the first place. And then we'll start little by little to add the functionality as we desired. Again, this is like coding partnership now. The model has a lot of knowledge that will help us, guide us through where we should start implementing the functionality that we desire. It will save us some reading maybe for the relatively boring part, like style sheets and how to modify and place the elements, and we can focus on the actual functionality, on the maybe like backend functionality or analytical parts, while also learning how these elements come together in a Shiny application, how we can customize here various UI elements, and it's a learning experience with a coding partner here that is aware of a lot of the designs for this Shiny applications.